10.3 geometric sequence and series worksheet. So let's just go through real quick. I should give you the formulas, then I don't see them here, but the formula for a geometric term is a1 times r to the n minus 1, and the sum of a geometric term is a1 times 1 minus r to the n over 1 minus r. Sorry, those will be given to you, and I should give you to them here. Find an for each geometric sequence. So first thing I'm going to do is write the formula. So a1 times 1 r times n minus 1. So that's our formula. So what's our first term? 2 over 9, where's our r3, and it's 7. So we want to find the 7th term. So we're just going to go plug my first term, 2 over 9, times my r, which is 3, and we'll plug in 7. So we get 2/9 times 3 to the 6. Now the most common mistake here is people do this first for some reason. Order of operations. This comes first. And something like this, I mean, you could leave it like that. I think that's a full credit. Because a lot of this is going to be a big number. You'll put in your calculator to get the answer. So you type in your calculator or leave it the way it is. And that'll be fine also. And I get 162. Generally they're bigger than 162. But that's the general idea. So just type it in, submit it. Same to the next one, right? I want to find the 7th term of the sequence. So I want to find a7 is what they're asking for. So write down the formula. an equals a1 times r to the n minus 1. What's my a1? 2,400. My r is 1/4. My n is 7. Again, I'm not going to be able to do this. Put in my calculator. This is what the 7th term is. Again, that's just telling you, oh, the 7th term is this. It's like here, the 7th term is 162. So we're just going to use the calculator, type it in, or leave it. Again, leaving it's totally fine also. I know what you're talking about there. To the 6, right? 7 minus 1 is 6. So I get 0.58599375. If let's make that a fraction. So if there's just a little hint, you have math and then fraction, you get the fraction version. Let's get that. Okay. Next. Write an equation for the nth term of the geometric sequence. So we just want the equation this time. So our geometric sequence is going to be an equals a1 times r to the n minus 1. What's our first term? a1 is 8. R is the tricky part here. So the way you find R is a2 over a1, or in general, an plus 1 over an. That just means you get one term we put over the one before it. So I can put 1/2 over 2. Or I can put 2 over 8. So in here, 2 over 8 is 1/4. That's my R. So my equation is just going to be this. And that is it. Again, a lot of common mistakes, people multiply these and give me 2. You can't do that. Order of operations, right? This goes to power first, then you go multiply. It's exponent, then multiplication. There's no parenthesis here. I mean, there's a parenthesis here just to show you that it's separated. There's actually no like parenthesis work going on. Just exponent, and multiplication. This comes first, so leave them separate. Next one, same problem, right? an equals a1 times r to the n minus 1. Again, a lot of this is super easy. 288 to my a1. Done. What is my r? All we gotta do is put the second term over the first term. Put this over that. Now I don't like negative 96 over 288. It's too big. I'm gonna put 32 over negative 96. Works the same way. Divide them both by 2. I get 16 over, what is that, 43? Not 43, 46. 46. Yeah, 46. I can divide by 2 again. And I get negative 8 over 23. That's probably as low as it goes. Negative 8 over 23. So my formula is going to be an equals 288 and negative 8 over 23 to the n minus 1. There's my answer. Next one, same thing. So I'm going to do it just a little fast real quick. an equals a1 times r to the n minus 1. That's my a1. R, again, you just put one of them over the next one. So we're going to put 6 over negative 3. And we get negative 2. So my formula is going to be an equals -3 times -2 and -1. Right, writing equation should be an easy thing. Until you get to this one. Right, so let's write an equation. So let's do what we always do. Write down the formula. An equals a1 times r to the n minus 1. Now I have r is 2. I don't have a1. Remember what I always say when you're missing something? Plug in what you do have. So we're going to plug in this. So when I sub in 3 for my n, I get 28. So that's what that means. When you plug in 3, you get 28. So this equation is going to be 28 equals a1 times 2, which is my r, to the 3 minus 1. I just plug in what I have. R is 2. This tells me the third term is 28. So when I sub in 3, I get 28, my value. All I gotta do now is solve for a1. So what is this? 28 equals 2 squared, which is 4. Alright, that's what this is. This right here is, 2 squared, which is 4. So now you divide by 4. A1 equals 7. And now I can write my equation. An equals 7 times 2 to the n minus 1. Right, so it's always the same thing. If you're missing something, go back to the original equation, plug in what you do have, and then find the missing thing. Same thing right here. So again, I have my r, I don't have my a1. So let's just write the formula down. Plug in what you do have. R is 1/3. When I plug in 4, I get 24, sorry. So when I plug in 4, I get 24. So like that. I just gotta solve it. 24 equals a1, the 1/3 to the 3. So 24 equals a1. That 3 goes to both, and I get 1 over 27. Times both sides by 27. I get a1 equals, I don't know what 24 times 27 is. I should. (648). So now I have my equation. An equals my a1, 648, times my r, 1/3, to the n minus 1. So there you go. So again, anytime you don't have a certain term, go back to the original equation and plug in what you do have. You should be able to find out the term you're missing, then go back and plug it into the original equation. Okay, now let's do a couple of find the sums. So we want to find the sum of the geometric series. So the formula is a1, 1 minus r to the n, over 1 minus r. So we've got to plug those things into my a1 is 16, my r is 1/2, my n is 9. So I'm trying to find the sum of the first 9 terms. It's going to be, not erasing the way I wanted to, 16 to the 1 minus 1/2 to the 9th power, all over 1 minus 1/2. Right? Again, we can leave it like that because that shows me you know what you're doing. Or you can put it in our calculator. Now, something like this is kind of ugly, so I would do alpha y equals, fraction up, do 16, 1 minus 1/2 to the 9th power, all over 1 minus 1/2, which is just 1/2. You can put 1 minus 1/2 if you want, but it's just 1/2. So whatever this answer is, we're going to times it by 2 essentially. And I get 31.9375. Or if we want a fraction, 5/11/16. Again, either of these are fine for me. Next one, same idea. I want to find the sum. So we have the formula, let's plug it in. Try and find the sum of the first 8. So it's the first term times 1 minus r to the term we want, all over 1 minus r. Same idea. Again, that for me is full credit. Or you put in your calculator. And go math. Alpha y equals 36 minus 1 minus 1/3 to the 8th power, all over 1 minus 1/3 or 2/3 if you want. Put the answer to yours, not to do what I did, which was wrong. Okay, now we get this. Again, we'll just round it this time. Approximately that answer. So to find sum is pretty straightforward. And you get into this one, right? So this one, 2 ways to do it. One is use the formula again. Because everything's there. Look at this is a geometric form. This is my A1. This is my R. This is my N. Right, so I could type it all in there, do the exact same thing. Or on your calculator, if it's updated, they do summation for you. If you go math, toward the bottom, there should be a summation. You can type it in. Any variable you want, put x equals 1, all the way to 8. We're doing -3 times -2 to the x minus 1. And get your answers. So right, both ways work. Type it into the equation like that, or do that. For A1 for each image tree is described. I had to go to this. Yeah, we have this one too. Okay. Okay. Find A1 for each image tree described. So they tell me the sum. So notice how they give me the sum. So I have the sum formula. Because that's what they give me. Now look what they have. I know the sum is -10,922. R is 4. And N is 7. So essentially, one thing I'm missing is A1. Right? I have everything except for A1. So just put in your calculator. All right, let me simplify what this is. Let's figure out what 1 minus 4 times is. Let's take this step by step. So all this is negative 16,383. So I have negative 10,999 equals negative 16,383 times A1 over negative 3. Again, I'm trying to do this out for A1. So multiply by negative 3, divide by that, and you're done. So I get negative 10,999 times that by negative 3. We're going to divide by negative 16,383. And we get negative 2.014 if I round to the nearest thousand. If I want a fraction, let's go math fraction. And you get that ugliness. That's an ugly A1. Did I type something in wrong? Maybe. But I'm going to move on. This is the exact same question. Sn equals A1 1 minus R to the N over 1 minus R. Again, you have everything except for A1. Just plug it in. So essentially I have negative 2912 equals A1 1 minus 3 to the 6 over negative 2. So we're going to multiply by 2 and divide by that. I'm just going to do it all on the calculator this time. So I'm going to say negative 2912 times negative 2. Then we're just going to divide by this guy. So you could do it, put parentheses. I meant caret, not that. Caret to the 6. And I get negative 8. Much nicer. I must have made a mistake on the first one, but I'm not going to go back. Anyway, A1 equals negative 8. Now we're going to talk about infinite geometric series. So, infinite series, sometimes it's infinite. You see it goes on forever. Some of those you could find the sum of, some of those you can't. When you can find the sum, it's called convergent. And that only happens when R is less than 1, absolute value of R. And when you can't do it, it's called divergent. That means there is no sum. It just goes on to infinity. You do that when R is bigger than 1. So that's all you got to find here. Is this convergent or divergent? All you got to find the R. Is it less than 1 or bigger than 1? Is the absolute value of it less than 1 or bigger than 1? So like the first one here. What's my R? A2 over A1. 63 over 21. That's going to be bigger than 1. So this is divergent. The next one. So this one, again, I gotta find my R, 9/8 divided by 3/4. That sucks. That's 9/8 divided by 3/4. Just rewrote it, and then I'm gonna multiply by the reciprocal, which gets me 1/2, 1/3. I get 3/2 out of it. So again, divergent, bigger than 1. 17. Again, R is just gonna be 360 over 480. That is less than 1, so this is convergent. That means I can find the sum. So if I was saying what's the infinite sum, I could find it for this one. 19, same problem. I'm going to do A2 over A1, so 10/9 over 5/6. So this is the same thing as saying 10/9 divided by 5/6, or 10/9 times 6 over 5. I get 60 over 54, 55, 45. I can do math sometimes. Bigger than 1, this is divergent again. Right, that's all it was. Are you bigger than 1 or less than 1? This one I'm bigger than 1, so divergent. Last part. So we want to find the sum of each infinite series if it exists. Now our infinite series has a different formula. It is this. Sum of infinite of a geometric sequence is A1 over 1 minus R. Much simpler. This only works if it's convergent, which means if R is less than 1. So that's the one we're going to use here. We just have to figure out if R is convergent or divergent and then do it. So this first one here is find our R, most important thing. So we're going to put -8 over 16, right? We put the second term over the first term. In this case, I get -1/2. So it's convergent. I can do it. It's less than 1. Again, absolute value, less than 1. So let's find the infinite sum. Infinite sum of this is just going to be A1, 16 over 1 minus my 1/2. It's like that. If you want to put in your calculator, you don't really need to though. This is 16. That'll be 3/2. And then it'll be 16 times the reciprocal. So I get 32 over 3. Again, if you want to call this point in your calculator. So you get 32 over 3 is the infinite sum of this, which is kind of crazy. You're saying if you start at 16, subtract 8 plus 4, subtract 2, and keep on going, it's just at the end turn out to be 32 over 3. Pretty crazy. Next one. Again, first you want to find out what R is. Second one, first term, -48 over 32. Now you're like, hey, that's less than 1, it's negative. Remember, I don't care about the sign, it's absolute value. This is actually bigger than 1. Absolute value, this is bigger than 1. So it's too big, can't do it. No infinite sum. You can only do when R is less than 1. Absolute value R is less than 1. So not possible there. Next one. R is going to be 40 over 32. Again, bigger than 1. Not possible. The next one. R is going to be 14 over 21. That's divergent. That's 2/3 divided by 7. So I could do the infinite sum here. So S infinity equals A1 over 1 minus R. So that's the same thing as saying 3 over 3. So I get 21 over 1/3. The same thing as saying 21 divided by 1/3, which is 21 times the reciprocal. So 63. Again, you can also put in your calculator, but no need to, if you ask me. Then we get down to this one. Infinite sum with this notation. Remember what I said before? This is geometric notation. This is your A1. This is your R. Hey, look at this one. R is bigger than 1. Not possible. Divergent. No infinite sum possible. The next one. A1's there. R is there. So you could do it for this one. The infinite sum is A1 divided by 1 minus 5/6. Again, you put in your calculator if you want. I'm not going to. And this is 6 over 6. This is just 8/3 divided by 1/6. That looks scary, but really this is just a divide sign. So it's 8/3 divided by 1/6. And so you just multiply by the reciprocal. 8/3 times 6 over 1. These reduce. I get 16. So all of that is 16. Okay. Last one. If fan is running at 10 revolutions per second, F is turned off, its speed decreases at a rate of 0.75 per second. Determine the number of revolutions completed by the fan after it's turned off. So it's basically asking, this is asking for an infinite sum. Where your R is how much you're staying 75% per second, so your R is 0.75, and we're starting at 10. That's what's going on here. You're saying you're starting at 10 revolutions per second. You're only keeping 75% of that rate. So, what's the infinite sum? So we're going to do the formula. R is less than 1, so we can do it. It's A1 over 1 minus R. So S infinity is going to be 10 over 1 minus 0.75. So that's going to be 10 over 0.25. 0.25 is the same thing as saying 1/4. So it's 10 divided by 1/4. Or 10 times the reciprocal. 40. So it does 40 revolutions before it turns off. Right? Because it's going on forever, so it stops. So that's why it's infinite sum. And that's the worksheet.